All right, third video from section 3.3, looking at our minimums and maximums on the graph. And we have four of them. Each one has, if you will, two different names. We're going to look at relative minimums or local minimums, relative or local maximums, global or absolute mins, and absolute and global maximums. All right, as I promised from the last video, this is where we're only going to use the y's, no x's. All right, so by definition, a relative or local min, a function f has a local minimum at c. All right, c is going to be the x coordinate. If there is an open interval I containing the c so that all the x's in the interval will generate bigger y's than the y coordinate for c. Then we call f of c, which is the y coordinate, a local min. Now, yes, it's a difficult looking definition. All right, what you're looking for are turning points. We're looking for turning points. That's what we're looking for. So here's a turning point right down here. This is not a turning point. That's an end point. It has to change directions. So if you think back to when we're talking increasing, decreasing, constant, I'm going from decreasing to increasing. All right, I'm looking for the bottom of a U shape, some change in direction right here. So this is the C that they're talking about in the definition. So f of c generates this y coordinate, let's call it -4, where all the rest of these x's in the interval generate a bigger y coordinate than -4. So at x equals -4, that's the c. This is the y coordinate -4 we put in our answer. That's the relative minimum, just the y coordinate. Now, there can be multiple relative or local mins. Again, remember, it's a short little interval at one turning point. Okay, so I follow my graph here. I'm increasing, changing to decreasing. Okay, that looks more like it could be a relative max. All right, follow my graph. I'm decreasing to constant. Here we go. Wait a minute. Right here, decreasing, change to constant. Wait a minute. Let's go back to this one. Decreasing, change to increasing. Decreasing, change to constant. So it appears that the left side of my interval, or the left side of where the turning point, must be decreasing and then change to something else. That will be a relative min. So again, right here at, in this case, x equals 0, that could be my c. My y coordinate is 4. Well, wait a minute. There's 1, 4. That's true. But the y coordinate stays the same. So all the other x's generate y's that are bigger or equal to my y coordinate at that particular c. So +4 is also a relative min. Sound good? I'm looking at the rest of my graph. We're constant, changing to decreasing. Well, okay, there's the first part, decreasing, but wait a minute, no turning point. That's an end point. All right, so no more relative or local mins. relative or local maxes. Well, all that has to change is this inequality symbol right here. Now the y-coordinate at that turning point has to be the biggest possible y-coordinate in this open interval. Okay, so now let's see. Well, that was a relative min. Again, no turning point. Here's a turning point right here. Increasing to decreasing. At that point right there, -1, 6. That C is -1. My f of C is 6. That y-coordinate is bigger than any other y-coordinates in this short little interval that I'm testing. So 6 is a relative max. Okay, so that was a relative min. So over here we're going constant, then to decreasing. Wait a minute, this is a turning point, and it too has the biggest possible y in a short little interval. Oh, notice what's happening here. Remember when we did the relative min, we said we had to be decreasing on the left side of the turning point. Decreasing on the left side. Look what's happening at this relative max. Now I'm decreasing on the right side. I went from increase to decrease. Constant to decrease. So at your turning point, if the right side is decreasing and the left side is something else, it's a relative max. So at this point, what are we at? We're at 3, 4. Oh, wait a minute. Relative max is 4, and it can be a min? Sure, it depends on the interval that you're looking at. This y-coordinate of 4 is bigger than all these y's here, and it's equal to all of those y's. That's a relative or local max. You can have multiple answers for relative mins and maxes. All right, absolute or global mins. Okay, and here's what we're going to do to the definition. We're no longer going to have a small open interval. Our interval is now the entire graph. All right, now we're looking at the whole entire graph. What is the lowest possible y-coordinate? And it's this endpoint right here. Absolute max and mins can be the endpoint. Endpoints are never for relative or local max and mins. Remember, local or relative max and mins has to be a turning point. Absolute or global max or mins is any point. So right here at this point, I'm at 6, -5. That is the absolute smallest possible y in my whole entire graph. That's my absolute or global min. And there can only be one of these. If there happen to have this curve here, touch down here at -5, I don't care. You still put -5. But you can't have like -4 and 4 because those were shorter intervals. Absolute means the whole entire graph. Absolute max, now we're going to go same whole interval. Now we want the largest possible y. That was way up here at the top of my graph. There's my overall biggest y value. Again, notice the only thing that changes in the definition is from greater than, which means that was the smallest y-coordinate compared to everybody else. Now it's going to be the biggest y-coordinate compared to the rest of the graph. So I'm at -1, 6, and that 6 is my absolute max, which means, yes, relative mins and maxes can be part of the absolute max and min. But again, only one possible answer. That's it.